Hey everyone, welcome back. Today we're going to be diving into uh, something really cool
Yeah,
that could totally change how we use AI.
it's a big one.
It is. We're talking about making AI leaner and meaner and faster.
Without losing the smarts, right?
Exactly. Like imagine speed boosts for your phone or even running complex AI on tiny little sensors, all thanks to some really clever compression techniques.
It's pretty mind-blowing when you think about the possibilities.
It is. So the paper we're digging into today is called Learned Compression for Compressed Learning. Have you ever taken a picture with your phone and it's this huge high-res file,
Oh yeah, all the time?
but then to share it or use it in an app, you have to shrink it way down.
Right, it's like making a blurry little thumbnail.
Exactly.
Yeah.
And AI often has to do the same thing with data, downscale it to work with it.
Yeah.
But what if there was a way to shrink the data without losing all that important
Well,
detail?
that's exactly what this paper's all about.
And the solution they propose is called WaLLoC.
Catchy, right.
Maybe not so much. It stands for Wavelet Learned Lossy Compression. Honestly, that name needs some serious unpacking.
I agree.
So, what exactly are wavelets, and why is this whole thing learned and lossy?
Okay, so imagine musical notes, right? Each note is like a different frequency, and together they make up the whole song. Wavelets kind of work like that. They break down data, any kind of data, into these different frequencies of information.
Oh, so it's not just for images.
Nope, not at all. And the learned part means the system actually figures out the best way to compress those frequencies based on what kind of data it's dealing with. Like it'll do things differently for images versus audio.
So it's not just blandly squishing everything down?
Definitely not. There's a real intelligence to it. And then the lossy part, that means it throws some data away.
Oh, that sounds bad.
But here's the key. It's designed to only toss the stuff that doesn't really matter for what the AI is trying to do. Like our eyes and ears wouldn't even notice that info's missing.
Oh, so it's like cleaning out your spam folder. You're getting rid of the junk, but keeping the important emails.
Perfect analogy.
Okay, that makes sense. But I'm still a little fuzzy on how all this actually helps AI. Does making the data smaller really make that much of a difference?
It makes a huge difference. First of all, it means faster processing. Think about it. The AI has less stuff to crunch through, so it can think way faster.
Okay, so no more waiting forever for my phone to, process a photo.
Exactly. And second, it means lower memory use. This is huge for running AI on devices that don't have a ton of storage, like our phones, or even tiny little sensors out in the world gathering data.
So we could be putting AI in even more places without needing bulky hardware.
Exactly. And here's where it gets really wild. This paper says WaLLoC can achieve compression ratios that are like way higher than what we've seen before. They compared it to Stable Diffusion, that AI image generator everyone's talking about.
I've seen some amazing stuff from Stable Diffusion.
Oh yeah, me too. But get this, WaLLoC can shrink images down to 135th their original size.
Wait, 135th? That's tiny. But hold on, doesn't losing any data, even if it's unimportant, make the AI, dumber?
It's not really about keeping everything, it's about keeping the right things. WaLLoC is super smart about getting rid of redundancies, but it keeps the core info that the AI needs. And actually, in some cases, they found that WaLLoC actually made the AI more accurate.
What? The AI was smarter with less data. How is that even possible?
It's kind of counterintuitive, I know, but by getting rid of the clutter, the noise, WaLLoC might actually help the AI zero in on the features that are most important.
So it's like decluttering your workspace. You get rid of the distractions so you can really focus on the task at hand.
Exactly. It's all about working smarter, not harder.
Okay, now I'm really intrigued. So to make sure WaLLoC wasn't just a one-trick pony, the researchers tested it on a whole bunch of different AI tasks, right?
Oh yeah, they wanted to put it through its paces. They did image classification, colorization, document understanding, even music source separation.
Whoa, a real variety show for AI.
Yeah,
And how did WaLLoC perform?
honestly. It kind of blew the other methods out of the water. It was faster, used less memory, and in a lot of cases, yeah, the AI was actually more accurate.
Okay, so we've got faster AI, smaller AI, and potentially even smarter AI. This is sounding like a pretty big deal. But before we get too carried away, let's dive into some of the nitty-gritty details of how WaLLoC actually works its magic.
The technical stuff, you mean?
Exactly. Stay with us, folks. We'll be right back after a quick break. Welcome back, everyone. We've been talking about WaLLoC, Pretty amazing new technique that's making AI faster and more efficient.
Yeah, it's really turning heads in the research community.
For sure. And before the break, we were digging into how it uses wavelets to like break down data into these different frequencies.
Right, kind of like separating out the bass, mids, and treble in music.
Exactly.
Full.
And actually, the paper has some really cool visuals that show what this looks like. It's kind of mind-blowing to see like a complex image get deconstructed into all these separate pieces.
Yeah, it's like you're seeing the building blocks of the image, and you can really tell how this wavelet thing helps pick out the most important parts.
So it's not just throwing away random bits of data.
No, no, it's much more targeted than that.
That makes sense. And, we touched on this earlier, but I want to make sure our listeners really get this. WaLLoC isn't just for images, right? This could be applied to, like, all sorts of data.
Totally. One of the most exciting things about WaLLoC is that it's not limited to just one type of data. Images, audio, sensor readings, even text, it can potentially handle it all.
Wow. So we could be talking about everything from self-driving cars to, like, analyzing tons of medical data.
Absolutely. It opens up so many possibilities for using AI in new and creative ways.
I'm starting to see why everyone's so excited about this. Okay, so let's talk about speed for a second. The paper mentions that WaLLoC's encoding, the part where it actually crunches the data down, is super fast.
Yeah, it's really optimized for speed, especially during that encoding step.
And why is that so important?
Well, speed is crucial for any kind of real-time application, like think about self-driving cars or analyzing live video feeds.
Where every millisecond counts.
Exactly. And WaLLoC is built for speed. Remember how we talked about Wavelet simplifying the data? Well, that simplification lets WaLLoC use a lot of linear operations, and those are lightning fast for computers.
So it's like finding a shortcut through the math.
Yeah, you could say that. And that speed boost is a game changer for a lot of applications.
Okay, there's one more technical thing I want to unpack before we move on. The paper keeps mentioning something called an entropy bottleneck.
Ah, yes, the entropy bottleneck.
It sounds kind of scary, to be honest. Can you break that down for us regular folks?
Sure, it might sound complicated, but it's actually a pretty clever trick that helps WaLLoC get those crazy compression ratios without losing too much information. It basically involves adding a controlled amount of noise to the data during the training process.
Wait, adding noise? Doesn't that make things, like, worse?
It might seem counterintuitive, but think of it this way. By adding noise during training, you're basically giving the WaLLoC system a harder workout. It forces it to be more robust and adaptable.
So it's like training for a marathon in all kinds of weather, so you're ready for anything on race day.
Exactly. And this robustness is key for getting those high compression ratios. The noise helps the system figure out which parts of the data are really essential and when the parts can be safely discarded.
It's like filtering out the static from a radio signal so you can hear the music more clearly.
That's a great way to put it.
I think I'm starting to see how all these pieces fit together now. We've got the wavelets breaking down the data,
Yeah.
the learned aspect tailoring the compression, the lossy part ditching the unimportant stuff, and then this entropy bottleneck making it all super tough.
It really is a clever combination of techniques, both old and new.
Hats off to the researchers who came up with this. Okay, so we've covered a lot of ground here.
Yeah.
From the basics of wavelets to some pretty advanced stuff, I think we've got a good handle on how WaLLoC works and why it's so cool. But now I'm really curious about the bigger picture. What does all this mean for the future? What could this do for the world of AI? Let's shift gears a bit and explore that, shall we?
Let's do it.
And we're back. So we've been geeking out about WaLLoC, this game-changing technique for making AI faster and more efficient.
Yeah, without sacrificing accuracy, which is huge.
Absolutely. We've talked about the nuts and bolts, but now I want to zoom out and talk about the impact, the real-world stuff. The researchers tested WaLLoC on all sorts of AI tasks, and it kind of crushed the competition, didn't it?
Yeah, it pretty much blew the old methods out of the water. Not only was it faster and used way less memory, but a lot of times it actually boosted the AI's accuracy.
So hang on, we're not just talking about AI that's quicker and smaller, but maybe even smarter. That's kind of wild.
Yeah.
What are some of the things that get you most fired up about this? Where do you see this going?
Oh man, so many areas. One that I'm really excited about is edge computing. Imagine running powerful AI right on your phone or on drones or even those tiny sensors collecting data out in the field.
So instead of sending all that data up to the cloud, we can just process it right there on the spot.
Exactly. Think about it. Personalized healthcare, responsive smart homes, cars that can actually drive themselves without needing to talk to some giant server farm in the sky.
That's incredible. It's like we're on the verge of this whole new era of AI, right?
Right.
What else? Are there other areas where this could have a huge impact?
Absolutely. I'm also super interested in what this could do for scientific research. Imagine scientists being able to analyze huge data sets way more efficiently. I mean, we could be talking about breakthroughs in astronomy, genomics, climate science.
It's like giving scientists a superpower to see patterns and insights that were hidden before. Right.
Exactly. And the exciting thing is we're really just getting started here. As researchers keep digging into WaLLoC and refining it, I think we're going to see even more like totally unexpected applications popping up.
It's amazing to think about what the future holds. Well, this has been an incredible deep dive. I think we've all learned a ton about why WaLLoC is causing such a stir. It's a real testament to human creativity, finding new ways to solve these really tough challenges.
Mhm.
So for our listeners who are, totally hooked now and want to learn more, where should they go? What would you recommend?
Well, the research paper itself is a great place to start. It's got all the juicy details. You can find a link to it in the show notes.
Perfect. And I would add, keep an eye on those online communities where researchers share their work, like our Schiff and GitHub. Lots of cool stuff happening there.
Definitely.
Well, that's about all the time we have for today's deep dive into WaLLoC. A huge thanks to our expert for walking us through this groundbreaking research.
It's been a pleasure.
And to all our listeners out there, thank you for joining us on this journey of discovery. We hope you've learned something new and exciting about the world of AI. And hey, don't forget to subscribe to the Deep Dive for more explorations into cutting-edge research. Until next time, keep those minds curious and keep exploring.